So welcome back. And so the last video of this lesson, we'll take a look at Apache HBase. So this is basically, again, we're going to look at the features. We're going to run interactively using HBase shell and list some of the access mechanisms. So HBase is essentially a scalable data store, and it's essentially non-relational distributed database that's using commodity clusters to store the data. And you're talking billions of rows when you're saying scalable. And this runs on top of HDFS, and it's got very tight integration. It's one of the applications that's really closely tied in with the Hadoop infrastructure. It supports compression, which basically lets you lower the network traffic and also the size of data on the disk footprint essentially. And the compression is fast enough that you can outweigh the cost of compression with these benefits. It actually has options to do some caching, so in memory operations. So it can cache recent edits in MemStore, and also when you're doing lots of reads, it will try to cache reads as possible, and that's also improving performance. So there's quite a rich optimization going on underneath the covers. So let's look at some of the features. The main thing that we should stress is it's got consistency, and basically this means if you transition a table from one valid state to another, it basically happens directly without intermediate changes. So like a row won't disappear if you're doing an update. This is important if you're looking at basically consistency of what you're reading in for your processing. It features high availability. It does this using lots of different optimizations and approaches. It's doing range partitioning of keys across servers. So this essentially spreads out the keys across various regions. And then you have data in HDFS, and if you remember, HDFS does replication, so that already gives you a little bit of high availability. It also lets you do, and the newer versions read high availability by having read-only copies in secondary regions. So lots of mechanisms to make sure that your data is available, essentially. HBase does automatic sharding. That is, the tables are essentially distributed when they become too large, and they're split over regions. So this gives you performance scaling. You can do replication, and by replication, I don't mean the HDFS piece. There's actually data replication you can do between HBase servers with different modes of replication, essentially. Master-master, master-slave, and cyclic. So this is, again, basically helping in terms of availability if something happens, essentially. There are security mechanisms, basically for both the server side and the client side. There's an authorization process you can set up for the client access, and even the replication that I was talking about can be secured. So a lot of options on that end. You can have SQL-like access. Lots of tools like Hive we talked about, Spark and Impala let you do that. Let's look at an example now. Again, we're going to do it interactively so that you can try this out on your Hadoop VM. So start the HBase shell. So do HBase space shell, and that should put you in the shell. And in this example, what we're going to do is create a table, put some data into it, and look at how those operations work. So creating a table, we are again creating a user table info. We are doing name, which is the username, basically full name, and then the home directory. So the command is up here. You can actually copy that as is and run it. So in the HBase shell, and I have a snapshot here that shows how that works. So that creates the table. Again, there's no data in it. So to put data, you essentially in the HBase shell use the put command, and you give it the table name, give it the row number, and then give it the column field that you want to populate. So in this case, I'm sticking in username and the value, which is VCSA in this case. So as you can see in the snapshot, I've gone through and filled in the usernames in all 3 rows, full name in all 3 rows, and then I do the same for home directory. So pretty simple putting in data interactively. Now, once the data is in there, if you do a scan on the table, you can actually see all the data that's there. And in this case, you can see the 3 rows and all the values that I put in. And you can try something else and have more rows or different values if you like. The key is you should use the names that you had when you created the table, essentially. You can actually scan parts of the data. So in this case, I'm just scanning the column which has the full names in it. And so I do a scan on the user table with the column name set to full name, and then you can see I get the 3 rows with just the full names. So simple operations. Again, HBase has a wide variety of things you can do with it, and we have a separate module for this also. This is again a quick way of looking at it interactively, just so you get familiar with how it looks. So we used an Apache HBase shell, but there are all kinds of other options. There's HBase via MapReduce, so you can write MapReduce applications that use HBase as the data source, sink, or both. There's a native Java API that you can use to directly interface. You can't obviously be typing in data all the time. There's a lot of non-Java APIs, C, C++, Thrift. There's a REST API. So all these are options that we'll look into in more detail in the module that's coming up. So that ends this lesson. Hopefully you got a quick overview of all the applications and also the types of use cases people cover with Hadoop-based applications, and also a quick introduction to how you might run these interactively on the Hadoop cluster. Go give it a try. And as I said, all these will have a lot more detailed modules coming up, so you can get more information in the upcoming lectures. Thank you.